Okay guys, today we're going to be doing 4.4, which is combining functions. So we're going to be using some function notation here. So just remember that f of x is saying that is representing a function. Okay, so we're going to see lots of f of x's today, g of x's, and h of x's, and some other letters too. So the idea here is that sometimes we have more than one function, and we want to combine these other functions. So real world applications of this are like, maybe I have a function that represents how much money I'm making at my job, and then I have a function that represents how much money I'm spending on ice cream every week. If I took the function about how much money I'm making minus how much money I'm spending on ice cream, I'm going to end up with how much money I actually have at the end of the week. So sometimes it's good to be able to combine functions. So we're going to go through some examples. We are going to add, subtract, multiply, and divide functions today. Here are some tips that you are going to want to keep in mind when you're doing this. First, use parentheses and use them carefully. In my opinion, I would rather overdo parentheses than underdo them. So make sure that you use lots of parentheses and write each function in a set of parentheses. Also be careful with negatives. If there's a negative outside the parentheses, it changes the sign of everything inside. That's one of the most common mistakes we see, is that people forget that negatives on the outside of the parentheses apply to everything on the inside. And then the next two tips are just about specific kinds of combining. So when you're adding and subtracting, remember the big idea is to combine like terms. And when you're multiplying, you are going to be distributing a lot. And make sure you use your exponent rules correctly. So let's just jump into some examples. I want to make sure that we are using these tips appropriately. So first, in these examples, I have three functions, f of x, g of x, and h of x. And I'm going to be combining them in different ways. So the first one is f of x plus g of x. So what I'm going to do is I'm just going to write out what f of x is, 3x minus 5, put it in parentheses, and then I'm going to add g of x. I'm going to choose to add, basically there's two choices for g of x. The one I circled in red is called factored form. We're going to talk about that a lot later. The second one is called standard form. And we are going to add the standard form equations together because then we can combine some like terms. If I had written the part of g of x circled in red, I would have had to multiply before adding. Okay, now I'm just going to start combining like terms. I'm just adding two polynomials together. So I have an x squared, I just have 1. I have a 3x and a 2x that I can combine to give me 5x. And then I have a negative 5 and a negative 3 that combine to give me a negative 8. So this x squared plus 5x minus 8 is my final answer. Okay, I'm going to let you guys do B and C on your own. Let's take a look at D. So D, we've got some multiplication and some addition happening. So with D, I have 2 times my f of x, so 2 times 3x minus 5, plus 3 times my g of x, so 3 times x squared plus 2x minus 3. So remember that when we have multiplication like this, we have to take the numbers on the outside, the 2 and the 3, and distribute them into everything on the inside of the parentheses. When I distribute that, I would get 6x minus 10 plus 3x squared plus 6x minus 9. And now I can start combining terms. So I have one term that has an x squared in it, so 3x. I have a 6x plus a 6x, which is 12x. And then I have a negative 10 and a negative 9, which combine to give me negative 19. So then 3x squared plus 12x minus 19 will be my final answer. Okay, I'm going to work through, let's see, I kind of want to do one that has an h of x in it, but I don't have any on this page. So I'm going to jump to one that's multiplication then. Let's look down at g. G is f of x times g of x. So my f of x, let me glance back up, is 3x minus 5. And then my g of x is x squared plus 2x minus 3. Now remember, when we're multiplying polynomials, what we have to do is distribute. So I'm going to distribute this 3x into all three terms in my second polynomial to get a 3x cubed plus 6x squared minus 9x. Let me switch colors. I'll do the next part in green. Then I have to distribute this negative 5 to everything in my second set of parentheses to get negative 5x squared minus 10x plus 15. Notice how careful I was with distributing not just a 5, but a negative 5 into everything. Okay. Oh no, where did it go? What have I done? Whoa, I just zoomed in super far. Didn't even know I could do that. So now I'm just going to start combining like terms. So I have a 3x cubed, I have a 6x squared and a 5x squared, and a negative 5x squared, which just leaves me with an 8 squared. I have a negative 9x and a negative 10x, which is a negative 19x, and then I just have this lone 15 at the end. So that one has an extra step in it, but it's not too bad if you just take it one step at a time. Okay, that's kind of a glance at what we would do if we were adding, subtracting, and multiplying these kinds of polynomials and functions together. Next, let's take a look at what happens when I start dividing. So let's look at this first example, I have f of x over g of x. So the first thing I'm going to do is I'm just going to write it out. So I have f of x, so 3x minus 5, over g of x, which is x squared plus 2x minus 3. Now, I'm actually going to write this in both ways. Remember how before we said there's actually two versions of g of x? There's the one that you have to multiply, and there's the one in standard form. I'm going to write it in standard form too, just that we see that you could write it either way. Okay. Now I'm going to show you why writing it in this second way, writing it in like the unmultiplied way, is better by looking at k together. Right? So k is g of x. So again, I'm going to use the unmultiplied form, x plus 3 over x times x minus 1, all over h of x. And h of x is x minus 1. And this is why it's nice to have them written out before they're multiplied. I have an x minus 1 on the top and the bottom, so I can cancel them out. They're gonna cancel each other out. Think about the x minus 1 on top as like I'm multiplying by x minus 1. And on the bottom, I'm dividing by x minus 1. And multiplying and dividing undo each other, so they cancel each other out. I'm just left with x plus 3. And that would be my final answer. So whenever you're dividing, you're going to want to, if you have the polynomial in a form that's like unmultiplied or the pre-multiplied form, you're going to want to use that just to see if you can cancel anything out. Okay. Let's talk a little bit about evaluating combined functions. So we've kind of already done this in our first unit. So in the first unit, we talked about how to do things like f of negative 3. And if you remember right, we would just go up to where f of x is, we take the negative 3, we plug it in for all the x's, and then we would simplify to get negative 9, and that's our answer. Okay. So we're just going to add a new layer to this, and the new layer is that now we're going to be combining functions and evaluating them at the same time. Okay, so let's take a look at, let's do e. That one looks a little messy. That might be fun to do together. So we have h of negative 2, so let's just go up, find h, plug negative 2 in. Remember to put my function in parentheses, so negative, and then x squared, I'm going to put that negative 2 in parentheses, minus 1, times 3 times, and I'm going to plug negative 2 into g of x as well. So negative 2 squared plus 2 times negative 2 minus 3. Okay, now I've got it all written out, and it looks pretty messy, but it's not too bad. So let's just go through and do some simplifying. So first, in this first set of parentheses, I have a negative 2 squared, which is just going to turn into 4. So I have a negative 4 minus 1 times 3. Let's just simplify everything in here. Negative 2 squared is positive 4. And then I have 2 times negative 2, which is negative 4, and then minus 3. So negative 4 minus 1 is negative 5. And then times 3, and then 4 minus 4 is 0 minus 3. So I have 3 times negative 3, which is negative 9. So I'm just left with a 5 times a negative 5 times a negative 9, which is going to be 45. So that 45 is my final answer to this problem. So I'm going to let you guys work through these other examples. Just remember to be careful, use lots of parentheses, and just make sure you plug in. Remember, the number in the parentheses next to the G or the F or the H goes in place of all of the X's in your functions. So I wanted to jump down here because I wanted to look at some story problems. So this is, I think, where the real power of this section comes in, because we can really use this idea of combining functions to answer a lot of really important questions. So let's just read through this example. A company estimates that its costs and revenue can be modeled by the functions C of x equals that nice thing and R of x equals 100x plus 75, where x is the number of items produced. The company's profit, P, can be modeled by this. P of x equals R of x minus C of x. Find the profit equation and determine the profit when 60 items are produced. So let's just start with this profit equation. Find the profit equation. So it already kind of gave it to us. We know that the profit is going to be equal to my revenue, which is like the income, minus the cost. So how much did it cost to actually produce those items? So here we can just kind of plug some things in. So we don't know what P of x is, but I do know what R of x is. R of x is 100x plus 75. Make sure I put my function in parentheses. And then my C of x is this 0.6 x squared, all that stuff up there. So write that in, 0.6 x squared plus 49x minus 150. Okay, now I can just do some simplifying and combining like terms. So P of x is going to be equal to, let's just do one thing before we start simplifying, because I have this negative on the outside. I'm going to change it to a positive, and I'm going to make everything on the inside the opposite sign of what it was to start with, so I don't get confused. So the profit is going to be a negative 0.6x squared, and then I have 100x minus 49x, which is going to be positive 51x, and then a 75 plus 150, which is going to be 225. So this equation is my profit equation. So notice that the input is x, and if we go back to the story problem, x is the number of items produced. So this tells us how much money I make, or my profit, if I produce x number of units. And this is a super important question. Companies need to be asking this kind of question all the time. How much money, how many products should I make to maximize my profit, right? So the second half of the question is determine the profit when 60 items are produced. So let's say I decide I'm going to make 60 things. How much money am I going to make? So the easiest way to do this would be to just find P of 60. So I plug in 60 for the x's to figure out how much money I would make when I make 60 things. So I'm just going to plug this into the profit equation that we just barely made up. And then I would just simplify this, and that would tell me how much money I'm making, which is definitely something that I would be interested in knowing. Okay, I'm going to start B with you guys, and I'm going to let you guys finish it for me. A service committee is organizing a fundraising dinner. The cost of renting the facility is $250 plus $3 per person. Or this equation, 3x plus 250, where x is the number of people attending. The committee wants to charge attendees $20 each, or the revenue is going to be, the income is going to be 20x times the number of people that are coming. How many people must attend for the fundraiser event to raise $500? So let's start just by thinking about how much money the fundraiser is going to make. We know the fundraiser is going to spend 3x plus 250, right? That is how much money they're going to be out. We also know that they're going to make 20 times the number of people they invite, right? So there's like my two functions that I care about. And we're going to take how much money we make, so the revenue, and subtract the cost, right? This is how much it's going to cost to rent the facility. And that's going to be my profit, or the money raised. In this case, I know a specific amount of money that I want to raise. I want to raise $500. So to solve this problem, I would take my equation that I just came up with, and I would set it equal to 500. So the key here is just thinking about what do each of the numbers and quantities represent.